Okay, today we're going to be looking at the area formulas for a triangle. And we know the standard area formula for the area of a triangle from geometry is 1/2 times base times height. Then we have a trig area formula. This one requires that we have an SAS configuration. So what that means is we have two sides of the triangle and we have the included angle. The area in that configuration is 1/2 times A times B times the sine of angle C. And angle C would be the included angle in between sides A and B. We also have a new formula called Heron's formula, and this one requires that we have an SSS, or a side-side-side configuration. That means we're given three sides of the triangle. And that one is area is equal to the square root of S times S minus A times S minus B times S minus C. And you might ask, what's S? A, B, and C are the sides of the triangle, but S is the semi-perimeter of the triangle, and the semi-perimeter is just half of the perimeter. So the semi-perimeter of this triangle would be 1/2 of the perimeter, or the three sides added together, 1/2 A plus B plus C. If you don't have an SAS or SSS configuration, we can also use law of cosines or law of sines to get the parts that you need for a specific area formula. All right, let's derive the trig formula for the area. For this, we will need an SAS configuration, so I'm going to make up some numbers. We'll have side A given to us as 17, side B given to us as 21, and angle C, the included angle, is 20 degrees. In order to get an area of a triangle in the traditional way, we need a base. Now, typically we think of the base as the bottom of the triangle, so we can certainly use B as 21 as the base. So the area of a triangle is 1/2 times base times height. So that's 1/2 times 21 times. And now the height of a triangle can be drawn in from the base to the opposite vertex, where the height is perpendicular to the base. So I'm going to call that the height of the triangle. And we can actually find the height of that triangle by considering the right triangle that's inside of the bigger triangle. When we draw in the height, we make a right angle, and so now we can use SOHCAHTOA, or right triangle trigonometry, in order to find the height of the triangle. So in the right triangle, we have the height as an involved side. We have 17, or side A, as an involved side, and for this right triangle, 17 is the hypotenuse, and then we also have C, which is an angle of 20 degrees. So thinking about that, H is opposite the 20-degree angle and 17 is the hypotenuse, so we can use a sine ratio. Sine of 20 degrees is equal to the opposite H over the hypotenuse 17. That one's an easy one to solve for H. H is 17 times the sine of 20 degrees. Then we're going to utilize that and plug in 17 times the sine of 20 degrees as the height. From here, I'm going to rearrange the multiplication, or the factors in the multiplication, a little bit. Since it doesn't matter what order in which we multiply together four numbers, I'll multiply it as 1/2 times 17 times 21 times the sine of 20 degrees. And if we look back at our original triangle, 17 is A, 21 is B, and 20 degrees is the measure of angle C. So we have area is equal to 1/2 times A times B times the sine of C. It comes from the traditional area formula for a triangle. Okay, let's do a few examples of finding area of a triangle. In this first triangle, we have triangle ABC. It doesn't matter if it's drawn to scale. So I'll just label the sides, or the vertices A, B, and C. We know that side A is opposite angle A, so side A measures 5. Side B is opposite angle B, so that measures 9. And the measure of angle C is 14 degrees. Notice that this is an SAS configuration. We have two sides and the included angle between them, so this means that we can use the trig area formula. Area is equal to 1/2 times A times B times the sine of the included angle, or C. And A, our first side length, is 5. B, the second side length, is 9. And C, the angle that's included, is 14 degrees. We can enter all of that into the calculator and get a decimal value fairly quickly. So we need to enter this in the scratch pad. If you go to the home screen and then press A, we can get in the scratch pad. 1/2 times 5 times 9 times the sine of 14 degrees. And we shouldn't need to enter the degree symbol if we're already in degree mode. If your calculator is set on fixed 3 for decimal places, it's going to round for us, and the area of the triangle is equal to 5.443 rounded to 3 decimal places. In the next problem, this is triangle XYZ. I'll draw triangle XYZ, doesn't have to be to scale. We can label the 3 vertices X, Y, and Z. Angle X measures 37 degrees. Angle Y measures 79 degrees. And since all 3 angles add up to 180, we can automatically find the third angle. 37 and 79 add up to 116. Subtract that from 180 and we'll get 64 for the third angle, or angle Z. We've also got side Z, which is opposite angle Z, measuring 21. Okay, we don't have a side angle side configuration for this one, so we can use the law of sines fairly easily to find a missing side. So using the law of sines, sine of 64 degrees over the opposite side 21 is equal to sine of 37 degrees over the opposite side, which would be, I guess, x, since it's opposite vertex x. Cross multiplying, x times the sine of 64 degrees is equal to 21 times the sine of 37 degrees. So now dividing, x is equal to 21 times the sine of 37 degrees over the sine of 64 degrees. Using our calculator, we can enter that all in at once. In order to get a horizontal fraction, you can use the template, the symbol template that gives us lots of different configurations. The fraction is the first one of those, and that's right next to the book key on your calculator. So we can just type in 21 times the sine of 37 degrees on the top, cursor down to get to the bottom of the fraction, and type in sine of 64 degrees there and press enter, and that's going to give us an x value of approximately 14.061. Now that's not our final answer, so we will want to store that value So I'm going to go back to the calculator. I'm going to store that value in x, since we called that x. It'll be easy to remember that way. To store a value, Control and the variable key. You'll notice that STO is right above it for store. And then just type in the letter x. And where's my letter x? And press enter. And that gives us that value stored. Now if we go back to the triangle, in the triangle using the trig area formula, area is equal to 1/2 times, let's see, we've got 21 and we've got 14.061 as our two sides that we know. And that would be times the sine of the included angle. The included angle between those two sides is 79 degrees. So we'll use that one. And then when we go back to calculate this, we just have to remember to use the stored value for 14.061. So 1/2 times 21 times the stored value that we used, which was x. And that stored value is x, and then times the sine of 79 degrees. And the calculator did not like that. I suspect that it's because I didn't put a times sign in between the x and the sine of 79 degrees, so it misinterpreted that. Let's put a times sign in between it, and all is well in the world, and the area is approximately 144.930. Last example, we want to find the area of a triangle with sides of 23, 26, and 31. Quickly, we have three sides, so this is an SSS configuration. That means that we can use Heron's formula. Heron's formula is the area of the triangle is equal to the square root of S, the semiperimeter, times S minus A, times S minus B, times S minus C. And S is the semiperimeter, so S is 1/2 times the sum of all three sides. And that turns out to be 40. So now we just need to type in exactly what we see there, which is the square root of 40 times open parentheses 40 minus 23. And then next set of parentheses, 40 minus 26. Next set of parentheses, 40 minus 31. And then just press enter, and our area is 292.711. A note on this one, should you forget to use the law of the Heron's formula, then we can use law of cosines instead to get an angle, and then use our area formula. Area is 1/2 times A times B times the sine of the included angle. Okay, so quickly on the next page, we've got a triangle, or rather two triangles, if we think about a quadrilateral being two triangles, and we're given the following. Measure of angle A is 90 degrees. Measure of angle D is 115 degrees. And we're going to be out of time.